Function flow. Previously, we learned about scope, the idea that variables inside a function cannot be used outside of the function, and variables outside a function should not be used inside the function. Further, we learned that functions do not consume or return variables. Instead, they consume and return values. These ideas are critical in understanding how data flows through a program. The goal as a programmer is to isolate variables to regions of the program, so that those regions are easier to think about without having to keep the entire program in your mind all at once. You can think of a program as a flowing, twisting river. Regular execution makes the river flow south, but functions disrupt this flow. Along the way, values are carried by the current. At times, we give these values names by using variables, but it is the values that flow through the program, not the variables. When you call a function, each parameter is assigned the value of a relevant argument. When you return from a function, the function call is substituted for the returned value. These are the only tools we should use in Python to move data around a program. This is just like what happens when you use an operator like plus or minus. Even though we do not see the substitution visually, it still happens. Each time we call a function, we say that its local variables are inside their own scope. We will also call this scope the frame, and it can be used to show the current variables and their values. Notice that the global frame is separate from the local frame. The frames shown here are from if we stopped the program right before the return statement got executed. After the return statement is executed, we would cross out the add_period stack frame to indicate that the function's scope has ended. To move data from one function to another, you cannot just look at the two functions. You must also look at where the functions were called. The returned value of one function should be fed into the next function. In the code shown, the variables defined inside calculate_grade are distinct from the variables outside of the function. In fact, it is only the last 4 lines that actually move values between functions. Without using return values and arguments, we cannot move data between functions. Things get even more complicated when functions call other functions, but this happens all the time. We are used to calling built-in functions, but we can call our own functions too. When we call a function inside another function, we stack the new function calls frame below the current frame, with the bottom frame being the current scope. When a function call ends, we remove that bottom stack and return to the one above it. Each function call's frame is separate from all other frames, even if they come from the same function or have variables with the same name. In the stack frames shown here, you can see that the number variable has different values in the different scopes at the end of the program. You can also see how some scopes have expired, resulting in their call frames being crossed out. Their data is no longer available.